Today we get to start relating what we know about radians to the unit circle. And we're going to relate it to sine and cosine of a radian measure of an angle instead of just the degree measure of an angle. But what's nice about this though is that it's very similar to the work that we did with degrees. Before we get started, I just want to remind you from our lesson yesterday on how to convert radians to degrees. We use the ratio 180 degrees over pi radians. So if I wanted to convert radians to degrees, I would take my radians and simply multiply them by 180 degrees over pi radians. So that's going to help us understand where radian measures are on the unit circle. So in example 1, part A, I want to find the sine of and the cosine of the given radian measure. So we want to find the sine of pi over 4 radians and the cosine of pi over 4 radians. So what we need to figure out is where is the angle pi over 4 radians in relation to our unit circle. So there's a couple ways that we could go about this. One way is if I'm talking about the angle measure theta being equal to pi over 4 radians. Well, if you recall from yesterday's notes, we discussed how a full circle has 2 pi. So a full 360-degree rotation is the same thing as 2 pi radians. And that would mean that half a circle, or 180 degrees, would be the same thing as 1 pi. So if the full circle is 2 pi, then doesn't it follow that half of the circle would just be 1 pi radians? So that means that 180 degrees, so here's my initial side of my angle. I'm going to do a full 180 degree turn, which brings me to the point -1, 0 on my unit circle. Remember, a unit circle has a radius of 1. So from the center to the side, that's 1 distance. So 180 degrees is at the same spot as 1 pi. So if we think about that in terms of pi over 4, that means that we're taking pi and dividing it into 4 parts, 4 equal parts. So to do that, wouldn't I take pi, which is 180 degrees, I could divide it into 2 equal parts, or in half. And if I divided it in half, it would be the y-axis, the positive y-axis here. And what degree rotation would that be? So our initial side's still over here. This degree rotation would be 90 degrees, which is the same thing then as pi divided by 2. So then if I wanted to find the fourths of that, wouldn't I just divide the half in half again? And the other half in half again? And now I have 4 equal parts. So 180 degrees, or 1 pi, just got divided into 4 equal parts. So this, 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 and this are all the same. So if this first one, then, isn't that pi over 4? And then 2/4 would be the same as 1/2, so pi over 2. Then 3/4 would be over here, 3/4 pi. And then 4/4 pi would be here, but 4/4 pi is the same thing as 1 pi. So we just found where pi over 4 would be, pi over 2, 3 pi over 4, and 4 pi over 4, or 1 pi. But we don't really care about these other ones. Really, all we needed was pi over 4. Well, if I divided this top half of the circle into 4 equal parts, how many degrees would that be? 180 degrees divided by 4 is 45 degrees. So isn't each of these angles then, this is 45 degrees, this would be another 45 making it 90, another 45 making this one would have been 135, and then another 45 would be 180. So that means that pi over 4 is the exact same thing as 45 degrees. Now that was a complicated way of explaining and connecting pi over 4 to 45 degrees. We could have just converted pi over 4 radians into degrees. So pi over 4 radians times 180 degrees over pi radians. Let's see if our conversion formula helps us come to the same degree as what we just figured out in our unit circle using a little bit of logic. So radians divided by radians cancels, pi divided by pi cancels. We're left with 180 degrees divided by 4, which is in fact 45 degrees. So pi over 4 radians is the same thing as 45 degrees. So this is 45 degrees. And we want to find the sine and the cosine of pi over 4. So if you recall from our work from last week, we need to use a right triangle to help us do that. So I'm going to create a right triangle using this point. Remember, the x and y values of that point are equal to the sine and the cosine values of that angle measure. That angle measure is 45 degrees, which is the same thing as pi over 4. Well, if this angle of the triangle is 45 degrees, this is 90, doesn't that mean this has to be 45 degrees as well? So we have a 45-45 degree triangle, 45-45-90, sorry, degree triangle. What do we know the length of our hypotenuse is? Well, this is a unit circle, and the hypotenuse is the same length as the radius of our unit circle, so this would have to be 1. Well, we know that this side length and this side length are the exact same, so if this is A, this would also be A, which means that A squared plus A squared is equal to 1 squared according to the Pythagorean theorem. So then A squared plus A squared is 2A squared, 1 squared is 1, divide both sides by 2, A squared is equal to 2, square root both sides, so A is equal to, I just saw a mistake, sorry. I divided both sides by 2, 1 divided by 2 is 1/2, not 2, sorry. So A squared is equal to 1/2. We have to square root both sides, so this is equal to the square root of 1/2. So A is equal to the square root of 1 over the square root of 2, which is 1 over root 2. But we can't leave root 2 in our denominator, so we're going to multiply. We have 1 over root 2, the denominator, and the numerator by root 2. So we end up with 1 times root 2 is root 2, and then root 2 times root 2 is simply 2. So we know that this distance here is root 2 over 2. This distance has to be the same, so it's also root 2 over 2, which makes the x value of this point as pi over 4, root 2 over 2, and then the y value is also root 2 over 2. So remember, the sine of the angle is equal to the x value of the point of intersection between our terminal side of the angle and the unit circle. So that means that the sine of pi over 4 radians is simply equal to, sorry, the sine is the y value, not the x value. Oh my goodness. The sine of the angle is equal to the y value, and the cosine of the angle is equal to the x value. So the sine is equal to the y value, which is root 2 over 2. And then the cosine of the angle, pi over 4 radians, is equal to the x value of the point, which is also root 2 over 2. So we just found the sine and the cosine of pi over 4. They're both equal to root 2 over 2. So why don't you go ahead and see if you can get started on part B without me. I will give you a hint. I would convert 7 pi over 6 radians to degrees by multiplying it by 180 degrees over pi radians. And then let that angle measure help you find where 7 pi over 6 would be on the unit circle, create a right triangle from there, and see how far you can get without me. So pause the video and then press play when you're ready to check your work. So after we convert 7 pi over 6 radians to degrees, we should end up with 210 degrees. So 210 degrees on the unit circle, if my initial side is here, 210 degrees, this is 180. 210 is just 30 degrees past 180. So 210 degrees is right here, which is the same thing as 7 pi over 6 radians. So 210 degrees and 7 pi over 6 radians are at the same place on the unit circle. So I know that, and hopefully you were able to get this far without me. Now, I know that 180 degrees ends right here, right? 210 degrees goes 30 degrees past that. So we can create a right triangle that's perpendicular to the x-axis right here. So with this right triangle, if this angle's 30 degrees, this is 90, that would make this angle 60 degrees. So what we've created for ourselves is a 30, 60, 90 triangle, which is awesome and helpful because there are rules that 30, 60, 90 degree triangles follow. So we know that all 30, 60, 90 triangles, so 30, 60, 90 triangles, have certain rules that they have to follow. The short side, you know what? I probably should have switched where I put the 30 and the 60 degrees, sorry. The short side we just refer to as s. Then to find the hypotenuse, it's always 2s, and then to find the longer leg, we always do the short leg times root 3. That should seem familiar. We've talked about 30, 60, 90 degree triangles before. We also did them in geometry last year. So from there, we have a 30, 60, 90 triangle in our unit circle. We know that the hypotenuse is 1 because it's a unit circle, and the hypotenuse is the same as the radius. So from there, we can figure out our short side. Well, remember the hypotenuse is equal to 2 times the short side. So if our hypotenuse is 1, that has to be equal to 2 times the short side. So the short side then would have to be equal to 1/2. Well, in our case, our short side is on the negative y-axis. So that means that this is negative 1/2. So the y value of that point is negative 1/2. Then to find the long side, which is along the x-axis here, we're going to take the short side, which is 1/2, and simply multiply it by root 3. So 1/2 times root 3 is simply root 3 over 2. But again, we're on the negative x-axis, so this is negative root 3 over 2. So the x value at that point is negative root 3 over 2. So that means that the sine of 7 pi over 6 is equal to negative root 3. Just kidding. Why do I keep messing that up today? Sorry. It's equal to the y value of the point, so negative 1/2. And then the cosine of 7 pi over 6 radians is equal to the x value of that point, which is negative root 3 over 2. There we go. And this should look so familiar. This is actually the exact same as the work that we did for the unit circle in degrees last week. So really, you don't even have to do all of this work. You could just look at your unit circle notes from last week, find the x and y value of the necessary points, and then tell me that the sine of that radian is equal to whatever that y value was. The cosine of that radian is equal to whatever the x value was. So as long as you know the equivalence between the radian value and the degree value of the angle measures, it's super easy, or simple I should say, to figure out what the sine and cosine of those angles are after you already know them from previous work. So now let's talk about part C, the sine of negative pi over 3 and the cosine of negative pi over 3 radians. So first, let's convert negative pi over 3 radians to degrees. So negative pi over 3 radians times 180 degrees over pi radians. Let's see, radians cancels radians, pi cancels pi, 3 goes into 180 60 times, so this is negative 60 degrees. All right, so negative 60 degrees then has a clockwise rotation of 60 degrees. So that is going to put our initial side here like usual. And then we're going this way 60 degrees. So here's our point of intersection. Let's create a right triangle. I'm just going to write that a little smaller here. I'm going to create my right triangle. And this was 60 degrees. Well, I mean, okay, it's technically negative 60 degrees. But when I talk about it in terms of a right triangle, I'm just going to use the positive value. So this is 60 degrees, this is 90. That makes this 30 degrees. So once again, we have a 30, 60, 90 degree triangle, which makes our lives super easy to deal with. Theoretically, I guess. So remember, for a 30, 60, 90 triangle, you have your short side, the hypotenuse is 2 times the short side, and then the longer side is the short side times root 3. So for a unit circle, or a triangle in the unit circle, the hypotenuse is always going to be 1. This distance right here is 1. So then the short side is going to be, remember the hypotenuse is equal to 2 times the short side. So if 1 equals 2s, divide both sides by 2, the short side would then be equal to 1/2. So this length right here is 1/2. Then so that's our short side. Then our longer side is the short side times root 3. So 1/2 times root 3. So 1 times root 3 is root 3. And then 2 times 1 would be 2. So root 3 over 2. So the long side is root 3 over 2. But because we're along the negative y-axis here, this would be negative root 3 over 2. So that means that at this point, the x value of this point is positive 1/2, and the y value is negative root 3 over 2. And that should match the point that we found on our unit circle last week, right? So this negative 60 degree angle is the same thing as negative pi over 3. They intersect the 60 degree angle, the negative 60 degree angle, the negative pi over 3 angle intersect the circle at the same point. Those x and y values didn't change. So the sine of negative pi over 3 is equal to the y value of that point, and the cosine is equal to the x value of that point. And there we